Machine learning models are built from data about real people, and both the data and the trained model can leak that information. Protecting privacy isn't a checkbox at the end. It's a chain of choices about what you collect, what you release, and how. Behind every training row is a person. Names, addresses, dates of birth, income, medical history. This is personally identifiable information, PII, and it deserves real care. The obvious move is to delete the names, but that is nowhere near enough. Even with the name gone, fields like zip code, birth year, and gender remain. These are called quasi-identifiers. And quasi-identifiers are shockingly specific. In this population of 2,000 people, the combination of zip, birth year, and gender makes 71% of them completely unique. Here's why that's dangerous. A linkage attack. On the left, an anonymous medical record, zip, birth year, gender, and a diagnosis, no name. On the right, a public voter list that has names alongside those same three fields. Match the quasi-identifiers, and the anonymous record is anonymous no more. We now know Dana R. has diabetes. This is exactly how real re-identifications happen. It's not only the raw data, the trained model can leak too. A model that memorized a rare training example can be prompted or probed until it repeats it back, names and all. This genuinely happens with large models. So how do we protect people? Let's walk through 4 ideas. From the simplest habit to the strongest guarantee. 1. Collect less. This is data minimization. If the task doesn't truly need a social security number or a full address, don't store it. The safest data is the data you never held. 2. Release totals, not rows. Instead of publishing each person's income, publish the average for a group. The useful pattern survives, but no single individual is exposed. 3. Generalize, so nobody stands alone. Take that exact record, zip 02139, born 1984, which was one of a kind. Broaden it. The zip becomes a whole region. The year becomes a decade. Now that description is shared by many people. Across our population, the share who are unique drops from 71% to 0%. That's the idea behind K-anonymity. 4. The gold standard, differential privacy. Suppose we ask a database, how many people were born after 1990? The true answer is 510. Instead of releasing that exactly, we add a little calibrated random noise, so each release comes out slightly different. Nobody can tell whether any single person was even in the data, yet every answer stays close to the truth. Differential privacy comes with a dial, called epsilon. A small epsilon adds lots of noise. Strong privacy, but a fuzzier answer. A large epsilon adds little noise, a sharper answer, but weaker privacy. You choose where to sit on that curve. And the strongest structural choice, keep the data where it lives. In federated learning, the raw data never leaves your phone. Only small model updates travel up and get combined into a shared model. The sensitive data stays home. So, your training data is real people. Anonymized is not the same as safe. A linkage attack can undo it. But you have real tools. Minimize, aggregate, generalize, add noise, and keep data local. Just remember, privacy usually trades off against accuracy, so it's a choice you make on purpose. Next, we start shipping. How to package a trained model so it can actually run somewhere.